have seen how to calculate the power spectral density of unipolar NRZ we have seen, and bipolar NRZ we have seen. Okay, I'll just list out here. I'm not going to do any derivation. I'll just write the final equation. Unipolar NRZ, you had got Sx of f as a square
Ma'am,
TB
screen
by.
is not visible, ma'am.
Oh, okay. Let me share the screen. Okay, now it's visible.
Yes, ma'am.
Okay, fine. Unipolar NRZ, Sx of f is nothing but a square TB by 4 sinc square FTB plus a square by 4 delta of f. This is what we have got finally. And when we try to plot the spectrum, the amplitude we have got as 0.5. This is at frequency f is equal to 0, and TB it is approximated as 1. Okay, when we have taken it in this way, the graph will be in this way. Okay, for this 1, 2, 3, so on like that. This frequencies, higher frequencies are eliminated because the magnitude is very less. That is the reason we will not consider that. And when we try to calculate the bandwidth, this will be only from here to here. Okay, and the bandwidth here is 1 by TB. This is what for we have got unipolar NRZ. And coming to the polar NRZ, we have got Sx of f as a square TB sinc square FTB. Here the bandwidth will remain same. But the amplitude is increasing to 1. Okay, so the DC component value here is more when compared to the previous one. Okay, it will be same in this way. These frequencies are neglected. This is Sx of f for the polar f NRZ, and again the bandwidth from here to here, it is again the same. Bandwidth is equal to 1 by TB only. Okay, bandwidth and bit rate are directly proportional, so bit rate RB is given by 1 by TB again. Okay, so this is what for polar NRZ. So we have next two formats that we'll see in detail now again. It is bipolar NRZ. Bipolar NRZ. Okay, so how will you calculate Sx of f in general? What is the equation you have? In general, what is the equation you have for bipolar NRZ? You have to memorize this. 1 by TB mod V of f whole square summation n is equal to minus infinity to plus infinity Ra of n e power minus j 2 pi f n TB. Okay, so this is what we need to find. This is what the equation we use to find power spectral density. Sx of f is nothing but the power spectral density. Okay, so I have already explained you why we will be using, why we will be calculating power spectral density curve. Okay, so again, in order to find bipolar NRZ, you need to know what is V of f, and you should also know what is Ra of n. Okay, in order to calculate Ra of n, okay, first let us go with V of f as the same thing we can use here, because even for bipolar, if you take the pulse, it will be like this only. Either it can be positive or it can be negative. If you just recall, in the bipolar format, I'll just draw the bipolar format initially, then I'll try to explain you. Hope you all remember how to plot the bipolar NRZ format. Okay, so let me consider I have 0, 1, 1, 0, 1, 0, something like this. Okay, so 0 will be 0, 1 will be like, I will take the positive here. This is also said to be AMI, alternative mark inversion. So if the first one is positive, the next one will be represented with negative. Again 0, first one positive, and the next 0 is 0 only. Okay, so if you observe here also, I have the for the one I have positive pulse, and for next alternate next one it will be negative. So the next one, whenever you're representing the next one, it will be the complement of the previous one. So anyway, here we are taking the mod. So when you take v of f, even if you get some negative value, since it is modulus, it will become positive only. Okay, so I can take the same v of t curve. One second. Same v of t curve, v of t curve, which is nothing but rect t by tb curve. Okay, where it will be from minus t by 2, minus tb by 2, minus tb by 2 to tb by 2, and its amplitude will be 1. Okay, so we can take the same thing. Okay, same this pulse only we can take. Okay, so here what I need to find? I need to find v of f. Step 1, I need to find v of f. V of f I need to find. Okay, find v of f. That is the step 1. So how will you find v of f? You know v of t. V of t is nothing but rect t by tb. Okay, so in the frequency domain, v of f will be equal to, can anybody tell me rectangular function, what will be there in the frequency domain? You people are able to hear me, right?
Sync, ma'am.
Yes, TB, sync, FTB. Okay, so I've got V of f. Now then in step 2, what I need to calculate? I need to calculate RA of N. Once again. Find RA of N. If I want to find RA of N, first I need to know how to represent the AK, because here the random variable is nothing but AK. AK is nothing but its amplitude can be it can be either symbol 1 or it can be either symbol 0. Okay, so here the random variable is considered to be that bit, whatever it might be. Okay, so if it is a symbol 1, it can be either a plus or it can be a minus, right? Because as I've shown you here, the first one, if it is represented with positive amplitude, the next one will be represented with negative amplitude. Okay, so that is the reason I'm representing it as plus minus. It is for symbol 1, symbol 1, and it will be equal to 0 for symbol 0. Okay, so let us take the case 1, when n is equal to 0. When n is equal to 0, in the sense, see, we are not shifting it, we are just taking the same waveform. Okay, so what happened? Okay, before this, let me write the equation for RA of n, then we'll go with the case 1. RA of n. RA of n is represented as summation I is equal to 1 to capital I AK minus n. As I've told you, you have to remember this AK minus n I pi. Okay, so now let me consider case 1. Okay, in case 1, let us take n is equal to 0. Okay, when n is equal to 0, it will be of same 1 0 1 1. Let me consider I have like this. Okay, so if this is AK minus n is equal to 0. So your RA of n will be equal to summation or RA of 0 is equal to summation I is equal to 1 to I AK into AK of I pi. Okay, so AK, the next AK will also be same. Okay, it will not it is not a shifted version. Okay, so since it is same, I can write this as like, see, if the first combination is 0, the next one will also be 0 only. If the first combination is 1, the next combination will also be 1. No, I mean to say, if AK value is initially 0, if I consider this as 0, this also will be 0 only. So what will be your AK will be 0 into 0. Okay, so product, what will be the product of this? Product of this will be equal to, what will be the product of this? 0 into 0, it will be 0, and then I will have probability. Okay, so how many events will occur? Only 2 events. Okay, so the probability here will be 1 by 2, and the probability here also it will be 1 by 2. Okay, so 1 1. Okay, so it can be either plus A or minus A. Okay, so plus A here, this also will be plus A, minus A here, this also will be minus A. Okay, and product of this will be a square, and also this will be a square. Okay, so this total probability for this event to occur is 1 by 2. So the probability here it will get divided. So for this the probability will be 1 by 4, and for this the probability will be 1 by 4. So the total probability will be 1 by 2. Any doubts you have here? Any doubts you have here? Are you understanding? Anybody want me to repeat that?
No.
It's not required, right? If anybody want me to repeat, you just answer me. Okay, fine. Nobody is answering, so I am considering that you are understanding. Anyway, for my satisfaction, let me write it again. Okay, so first let me consider the first bit is a 0. So if that is 0, the next one will also be 0 because it is not the shifted version. So what will be your AK value will see, and product of those two will see, and probability of that event will see. Okay, so when A is 0, AK is 0 and AK is 0, it will be 0 0. Amplitude will be 0 0, right? So when you get a bit 0, how we have represented? We have represented with 0 volts only. Okay, it is 0 volts. Okay, so 0 volts into 0 volts it will be. So product will be 0 square, it will be 0. And the next event, unless and until we finish writing these events, we will not be able to write the probability. Okay, the next event can be 1. Okay, 1, if that is 1, the next one will also be 1 only, because it is not the shifted version, it is a same one. Okay, whatever we are taking here, the same thing will be here also. So here I am, so I will get only 2 events here. So the probability of this will be 1 by 2 and the probability of this will be 1 by 2. Okay, now AK is 1 and this also it is 1. Okay, so what happens to the product? This can be plus A. I'll write in terms of A and minus A. So 1 and 1. Okay, 1 can be positive A. So if this is positive, even this will be positive only. Okay, so the product of that will be A square. If this is negative, because I don't know, here at this location if you see, I have minus 1, minus A and minus A, right? So here if you take, it is plus A. So A into A square. Okay, here again I have minus A. So minus A and minus A. So what is the product? A square. Okay, so the total probability of occurring this event is 1 by 2. So what will be the probability of occurring this event separately and this event separately? It will be 1 by 4, 1 by 4. So the total probability will be 1 by 2 here. Okay, any doubts here? Any doubts here? Okay, fine. So now I'll calculate RA of 0. RA of 0 is equal to, you take accordingly, 0 into 1 by 2, product into 1 by 2 plus A square into 1 by 4 plus A square into 1 by 4. So this will be equal to A square by 4 plus A square by 4. So this will be equal to A square by 2. This is RA of 0. Okay, case 1 I have finished. Now let me take case 2. Okay, so if you just recall, in the for the previous two formats, we have taken n not equal to 0 directly, but here I cannot take it like this, but I'll take it as n is equal to 1. The reason behind that is, see, if I have some event, some sequence like this, 1 0 1 1 1. Okay, so what happens here? If I represent with positive here, negative, then again this will be positive and this will be negative. Okay, so what I'm doing, I'm just considering one shift here. Okay, one shift here. It's because, see, if this is positive, the next one can be either positive or negative. See, it may be like this shifted version. I'll just draw the shifted version. One second. 0, negative, then positive, then again negative. This is 0, negative, positive, again negative, and again I may have positive. Okay, so here if you observe with one shift I may have either a minus or I may have either a plus. Okay, that I don't know. Okay, that is the reason what I'm doing. I'm considering n is equal to 1 here also. Okay, here separately for n is equal to 1 or I'm considering. Okay, so what happens here, I'll just show you. I'll show you in the form of tabular column, maybe you'll understand it clearly. So again, array of n is equal to summation I is equal to 1 to I. Here I need to find out how many products I'm going to get here. So sorry, ak into ak minus 1 here I pi. Okay, so again let us denote it in the form of tabular column. Okay, so the data can be data like how I've represented before. In the same way I'll represent here also. First this AK can be 0. If it is 0, the next probability is it can be a 0. Okay, if it is 0, the next probability is it can be a 1. Okay, it can be a 1. Okay, so this is AK minus 1. What will be the values that we'll see, then product of those two, and then what will be the probability that we'll see now. Okay, so let us write this first. 0 0 0, so this will be 0 and this will be 0. It will be 0 0 square, it will be equal to 0. This into this, it will be 0 square, so it will 0 square will be equal to 0. Okay, next 0, so 0 is represented as 0. 1 can be, I may either have plus a or I may have minus a. Okay, so here for this particular event, I'll get two events separately like this. So here again 0 into minus a, plus a, it will be equal to 0. 0 into minus a, it will be equal to 0. Okay, let us first find out the events and then after that we will write the probability. Next possibility is 1. I may have a 1, or if I have a 1 I may have a 0, or again if I have a 1, my next event can be a 1 again. Okay, so here if you observe a 1 can be a, it can be either a positive a and this 0 will be 0. Okay, and 1 can be either negative a or it can be a 0, and this one will be 0. Okay, anybody has doubt here? I'll just rewrite this again. Okay, so I have a 1. This one can be either a positive a or negative a. So let me first take as positive a. Okay, so the other one is 0. So this will be 0. The one can be, first initial I have taken plus a, so it can be minus a also. Okay, so minus a 0. Okay, so it will be plus a into 0, which will be equal to 0, minus a into 0, it will be equal to 0. Okay, anybody have doubts here? Anybody have got doubts here? Okay, fine. Next, I'm going with the last case. Okay, so this one, if this one is plus a and the immediate one can be minus a also, minus a, right? If this is plus a, the other one will be minus a. I'll just show you here. See, if this is plus, the immediate next one is minus. Okay, so since you are making one shift, okay, so those two you need to compare. Okay, so that might be the possibility, or I may have a minus a. So if this is minus a, the next one can be, the next one should be plus a. Okay, anybody has got doubts here? Anybody has got doubts here? I'll just explain again. One can be plus a or it can be a minus a. Okay, so if the first AK is 1, I've just taken as plus a. So what is the possibility of getting next shifted version AK minus n? Okay, AK minus 1 is a one shift. Okay, so one shift I may have, I should definitely have minus a only. Okay, if I have plus a here, the next one will be represented with minus a. I'll just show you one example. So same 1 0 1 1 only I'll take. So 1 0 1 1. Let me consider this as AK. Okay, AK representation is in this way. Positive I've taken. So negative here. Again for this it is positive. Now I need AK minus 1. Okay, when it comes to AK minus 1, it will be shifted, right? So I'll have okay, so here if you observe, this is minus, this is a plus. Okay, it is shifted version. So if I have a negative one, I've got a positive one. In the same way, if you have a positive one, my one shift will have the negative one. Okay, because are you all able to visualize this? Whatever I'm explaining you, huh? Are you all able to visualize it? Whatever I ask you, you people won't respond only. That's what. See, if the first A is positive, the next A will definitely be minus A. If the first A is minus A, first one is minus A, the next one will be definitely plus A only. Okay, the reason behind that is here we are considering one shift. One shift we are considering k minus 1, only one shift. It can be either k plus 1 or k minus 1, both will be same only, because you know that it is symmetric waveform. This autocorrelation function is a symmetric function. Okay, that too even symmetric function. Okay, so that is the reason either you take ak plus 1 or ak minus 1, it will give you the same value. Okay, so plus a minus a minus a. So what will be the product here? Plus a into minus a, it will be minus a square, minus a into plus a, it will be minus a square. Okay, so can you tell me how many number of events occurred here? How many number of events occurred? Can anybody tell me how many number of events occurred? Total
7.
number of events. 7, but only this data bits you consider.
4.
4. Okay, so what will be the probability here?
1 by 4.
1 by 4, 1 by 4, 1 by 4, 1 by 4. But again here I have sub events. Okay, for this the probability will be 1 by 16. For this, 1 by 8.
By 8.
Okay, and for this it will be 1 by 8. And again for this it will be 1 by 8. Again for this it will be 1 by 8. For this it will be 1 by 8. For this it will be 1 by 8. Okay, so hope this is clear to all of you. Now what I need to do, I need to find RA of 1. Okay, RA of 1 is equal to just you multiply the product and the probability. So 0 into 1 by 4 plus 0 into 1 by 8 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 plus minus a square into 1 by 8 plus minus a square into 1 by 8. So it will be equal to, just simplify it, it will be just equal to RA of 1 will be equal to, anyway this is 0, this is 0, this is 0, this is 0, this is 0. I will be left out with minus a square by 8 minus a square by 8. So this will be equal to minus a square by 4. Okay, this is for RA of 1. Okay, next case, I'll take case 3 where n greater than 1. N greater than 1. Okay, case 3 I've considered n greater than 1. It is not the immediate shift, it can be anywhere. Okay, so in that case, again what is the RA of n? I need to find. So summation I is equal to 1 to I AK minus n I Pi. Okay, so again I'll write the tabular column. Data AK minus n, product of these two, product, and then finally Pi. Okay, so data points. Okay, let me start with 0 only. So 0. First thing, it can be either a 0 or if the first AK is 0, the next one can be a 0. If the first AK value is 0, the next one can be 1. Okay. Next, in the same way, I'll just write the events. The first AK can be 1. If this is 1, the next one can be either a 0. In the same way, the next one can be either a 1. Okay. So understand this. The first three cases are same as before. So this is 0, 0. No ambiguity here. Just 0 square, it will be equal to 0. Anyway, I've got, see, only this many events I'll get right, not more than this event. I will get only 4 combinations, 0, 0, 0, 1, 1, 0, 1, 1. That's all the combinations I'll get. Okay. So the total probability here will be 1 by 4. Here it will be 1 by 4, here it will be 1 by 4, and here also it will be 1 by 4. Okay. Now let us see. 0, 1. The first one can be 0. So if the first one is 0, the next 1, this one can be either a plus A or minus A. Okay. So 0 into plus A, it will be equal to 0. 0 into minus A, it will be equal to 0. And the probability here will be 1 by 8, and here also it will be 1 by 8. In the same way, 1. This 1 can be either a plus A or minus A, and 0 will be 0 only. So here it is plus A into 0, which is equal to 0, minus A into 0, which will be equal to 0. Here also the probability will get divided equally between these two events for this particular event. Okay, now the problem starts. Okay, so the first A is A. Okay, I'm representing the first A is A. Second A, it can be either plus A or it can be minus A, because it is not the one shift. Okay, this n value is not one shift. It is it is greater than 1. Okay, greater than 1 in the sense it can be 2, 3, whatever it might be. Okay, so if the first one is A, the next one can be A only, or it can be minus A also. Have you understood why it is in this way?
Yes, ma'am.
Anybody has got doubts, please tell me. Okay, next one. The first A I'm representing with minus A. Okay, if this is minus A, the next one can be either plus A or it can be minus A. Okay, the reason behind that is here we are not going with the one shift. So 1 0 1 1 0 1 0, something like that will take. So 1 is positive, then 0, negative 1, positive 1, 0, negative 1, 0. Okay, positive, negative, positive, negative, like this. Okay, let me consider I have shifted 2 times. Okay, 2 times in the sense I'll have like this: negative, positive, negative, positive, 0, 0, minus 1, 0, something like that it goes. Okay, so it is not immediate. See, if you take here, here I have got plus plus A. Okay, so here I may have minus A. Okay, here also, here I have, okay, I've got the events in this way. No, wait. Okay, let me take this and try. Positive, negative, positive, negative, 0, positive, 0, negative, positive, 0, negative, positive, negative, positive, negative, positive. Okay, let me take 2 shifts. So let me start from here. Okay, so this will be like this: negative, then I'll have a positive, then negative, then 0, then I'll get a positive waveform, then it is 0, then it is, once again, I'll try. I don't know for this sequence, however I want, I will get it in that way or not. This is AK, this is AK minus 2. Okay, So 2 in the sense like I'll just shift it to the left. So negative first, positive, again negative, then 0, then 1, 0, negative, positive, negative, positive, 0, something like this I've got. Okay, so this is positive A, the other one is minus A. This is negative A, and again here also I have negative A. Okay, so again this is minus A, this is plus A. Okay, so this is plus A, this is minus A. I didn't get a plus A combination, but anyway maximum combinations are covered. So here if you observe, see this, here I got plus A and here I got minus A. Okay, so this one is plus A, so the next one can be minus A. So this one is minus A, the next one can be minus A only, or this one is minus A, the next one is plus A. Okay, except plus A combination I've got everything else. Okay, 3 other combinations I've got. Okay, so that is the reason I've taken, if I have 1 combination here, so 1 combination. So if the first is first symbol 1 is represented with A, the next symbol can be plus A. Okay, if the first symbol is A, the next symbol can be minus A. Or if the first symbol is represented with minus A, in this case minus A here, next one can be plus A. Here plus A, minus A. Okay, so all this somewhere minus A here, minus A here. So all the combinations I've got. So if the first one is represented with minus A, it can be either plus A or minus A. So again we'll take the product. A into A, it will be equal to A square. Here it will be A into minus A, it will be equal to minus A square. Minus A into A, it will be equal to again minus A square. Minus A into minus A, it will be equal to plus A square. So what will be the probability of each event here? Total probability should be 1 by 4. So each probability will be
1 by 16.
1 by 16. 1 by 16 here, 1 by 16 here, 1 by 16 here, and 1 by 16 here. Okay. So that's all. Now we can calculate area of n. Okay, so let us write the area of n. Area of area of n will be equal to area of n will be equal to product is 0. 0 into 1 by 4. 0 into 1 by 4 plus 0 into 1 by 8 plus again 0 into 1 by 8 plus again 0 into 1 by 8. How I'm writing this is clear to all of you, I think so. 0 into 1 by 8 plus here a square into 1 by 16 plus minus a square into 1 by 16. Here plus minus a square into 1 by 16 plus a square into 1 by 16. Okay, so finally this entire thing we can write as 0 plus 0 plus 0 plus 0 plus 0 plus a square by 16 minus a square by 16 plus a square, sorry, minus a square and again minus a square by 16 plus a square by 16. Okay, so here plus a square minus a square by 16 minus a square plus a square by 16, it will get cancelled. So finally I will have area of n will be equal to 0. Okay, so everybody please note down this అవునా
డాడీ ఆయనకి
ఏమని
మీరు ఎప్పుడు రిజిస్టర్ చేస్తారు సర్వేలు ఎప్పుడు ఇస్తారు
అని నా డాడీ అడుగుతున్నాడా
కాదు, ఆయన
ఫస్ట్ ఇది తీసుకురా Hope you people are able to see my screen now. You are able to hear me also, right?
Yes, ma'am.
Okay, fine. There was some power interruption, so I could not like it got disconnected. Okay, fine. So we've got array of n, which is nothing but 0. Now I'll summarize everything. So array of n will be equal to, when it was 0, when n was 0, what was the term we have got? When it was 0, I got a squared by 2. When it was 1, I've got as minus a squared by 4, and then greater than 0, it was 0. Okay, so what is that? Array of n is equal to a squared by 2. Somebody please tell me whether what I'm writing is right or wrong. A squared by 2 for n is equal to 0, minus a squared by 4 for n equal to 1. Okay, and equal to 0 for n greater than 1. Okay, so as I've already mentioned, for n equal to plus 1 or minus 1, for both this value will remain same. Okay, the reason behind that is autocorrelation function is even symmetric. You have proved also in DSP lab, we have conducted this experiment. Okay, so now let us substitute everything. So what is Sx of f? Sx of f is equal to 1 by tb mod v of f whole square summation n is equal to minus infinity to plus infinity array of n e power minus j 2 pi f n dp. Okay, so what I'll do, I will take array of 0, array of plus 1, array of minus 1 separately, and v of f we already know, we have already calculated. So this can be represented as array of 1. First let me take array of 0. Okay, array of 0 into e power 0. Okay, plus array of 1 plus 1. So it will be e power minus j 2 pi f tb. Right, n value I've considered as 1. Okay, now I'll take array of minus 1. So array of minus 1, it will be equal to e power j 2 pi f tb. Plus minus into minus 1, it will be plus, so e power j 2 pi f and tb plus rest all I'll take separately. N is n greater than n not equal to 0, and I'll write it n is equal to minus infinity to plus infinity, but n is not equal to 0 comma 1. Okay, because I've taken them separately, 0 comma 1 comma minus 1. Okay, array of n e power minus j 2 pi f n tb. Okay, now let us substitute array of 0 values. So this will be equal to 1 by tb mod v of f whole square. Still I've not substituted v of f equation. I'll substitute it little later. Okay, into array of 0 is nothing but a square by 2 into e power 0 will be 1 plus Array of 1. Array of 1 is nothing but minus a square by 4 into e power minus j 2 pi f tb. Plus array of minus 1. Array of minus 1 value will also be same, because n is equal to plus 1, n is equal to minus 1, it will be same only. Autocorrelation function is an even symmetric function. That is the reason its value will remain same. It will be minus a square by 4 e power j 2 pi f tb plus array of n value for n greater than 1 is 0. 0 into e power minus j 2 pi f n tb. Okay, so I'll rewrite this. This will be equal to 1 by tb into mod, that I'll substitute v of f value, I'll substitute it is nothing but tb sinc f tb whole square into a square by 2 minus a square by 4 e power minus j 2 pi f tb, and here it is minus a square by 4 e power j 2 pi f tb. Anyway, 0 into something, it will be equal to 0 only. Okay, so I'll not take this term at all. Okay, so it is equal to 1 by tb into tb square sinc square f tb. Here I'll write a square by 2. Here what I'll do, I'll take minus a square by 4 common, so that I'll be left out with e power minus j 2 pi f tb plus e power j 2 pi f tb. Okay, so this tb in the denominator and 1 tb in the numerator will get cancelled, so I'll be left out with tb sinc square f tb into a square by 2 minus a square by 4 e power j theta, e power minus j theta, e power minus j theta plus e power j theta can be represented as
2 cos theta.
2 cos theta. Okay, so here I can write as 2 cos theta. In place of theta, you have 2 pi f tb. Okay, let me erase this. Oh, it's about to time up now. I'll just finish this fast. So this will be equal to tb sinc square. I'll take a square by 2 common. A square by 2 common. So a square by sinc square f tb into a square by 2 I've taken common, so I'll be left out with 1 here, minus 1 by 2 will be there, 2 cos 2 pi f tb. Okay, so this 2 will get cancelled, so this is equal to a square by 2 tb sinc square f tb. Okay, 1 minus cos 2 theta can be represented as 1 minus cos 2 theta can be represented as 2 sin square theta. Okay, I'll use the same thing. So it is 2 sin square pi f tb. Okay, so this 2 and this 2 will get cancelled. So I'll be just left out with a square tb sinc square f tb into sin square pi f tb. Okay, so generally the sinc square function will be in this way. Okay, and sin it will be in this way. So when you multiply these two, the final equation will be in this way, and normalized, so it will tb, by considering tb is equal to 1 and a square value is equal to 1, it will be equal to 0.5, and the spectrum will be in this way. Each and every value we need not calculate here, we'll just draw the graph roughly. Okay, it will be like this. Again, this is 1, 2, 3 like that. So again, to calculate the bandwidth, we'll take from here to here. Okay, so bandwidth will be equal to 1 by TB. Okay, but the advantage here is when I was talking to you, I told that bipolar format is advantageous because if you observe the DC component value is 0. Okay, since the DC component value is 0, it will not draw much DC power. Okay, so the power wastage will be less. That is what the advantage of this. And the RB will be equal to 1 by TB. Okay, so that is all related to this bipolar in RZ format. Okay, still you have one more. We'll see that in the next class. Shall I take a class in the afternoon? Is it okay? Because I'll just finish that. With that, the complete first module will get over. One more, maybe I'll take for 20-30 minutes and I'll leave you. Shall I take?
Yes, ma'am.
Yes, I'll take and I'll finish it off, ma, because again, next module, like the portions are huge only. Like I need to finish 4 topics, but still, it's all of derivation kind only, so it takes time. So that's the reason. Let me take class today only. Shall I take immediately after your fourth hour, or you want to break for some time? Hey, what I'm asking, Syed? Syed?
Ma'am, we need, ma'am.
Huh?
We need break, ma'am.
Okay. So shall I start in the regular time, 1:30 only?
Okay, ma'am.
Okay, fine. Now everybody please be ready. Don't miss the class because all these are derivations you are seeing. There are lot of equations also. Okay, so make sure that you attend the class properly. Okay, ma'am. Okay, that's all. You can leave now. Okay. Again, I'll send you link at 1:30. Same link only I'll be sending. You can join through the same link. I'll send you again. Don't worry. Okay. Thank you.
Thank you, ma'am.
Thank you, ma'am.
Thank you, ma'am.
Thank you.
Thank you, ma'am.
Thank you, ma'am.